Rainbow Rare Earths is focused on the development of the Phalaborwa Rare Earths Project in South Africa and the earlier stage Uberaba Project in Brazil. There have been several updates, and to talk me through their significance, I'm delighted to be joined by the Chief Executive, George Bennett, and Roux Wildenboer, Senior Metallurgist. So, George, it's been 2 years since you and I have last spoken, so there's a lot to catch up on. And you've just released an update on the Phalaborwa Project and the progress that's been made there, paving the way for the first commercial-scale recovery of rare earths. So if you could expand on this for me.
Hi, Sarah. Great to talk to you again, and thanks for having me this morning. I'm pleased to say we announced an update last week, and it's another progress update on Phalaborwa. And hopefully, the market sees that every time we do come out with an announcement, we are making positive progress. So we keep going towards our ultimate goal, which is to produce commercial volumes of rares out of phosphogypsum at Phalaborwa and other opportunities around the world. This latest update is basically, as you mentioned, highlights the fact that we've now achieved we've achieved a commercial route to producing separated rare earth oxides from phosphogypsum. We've produced a saleable product, first of all, in South Africa at Mintec, which was what they call a mixed rare earth carbonate, but we're not stopping there. We're going all the way through to separated rare earth oxides. We've managed to have a successful pilot plant running in Florida in America using continuous ion exchange and continuous ion chromatography. And basically, we've produced 96 to 97% purity of separated neodymium and praseodymium, two of the key mega rare earth oxides that we aim to produce. And these are saleable product. And we've established that fact, and we would just suffer a small impurity discount. But now what we're doing is we're also moving that pilot plant from Florida to South Africa to optimize the final purity up to 99+% purity, so we can achieve a full 100% payability on our separated oxide grade that we'll produce out of Phalaborwa.
So you've also announced multiple optimization opportunities of the flow sheet that you've developed from the preliminary economic assessment. Can you give us more flavour, more insight into this?
Yes, thank you. You're quite right. At our preliminary economic assessment in October 22, we had an economic flow sheet which produced very, very good financial model numbers, an IRR of over 44%, EBITDA margin of over 75%. And at that stage, at spot rare earth pricing, we would have produced $190 million per annum of EBITDA on a $200 million capex number. Now, the optimizations that we've been able to achieve by running an extensive pilot program over the last year in South Africa at Mintec has highlighted some of the opportunities, as we've mentioned, that we can remove from the flow sheet and still have a very economic flow sheet. And what this is doing, it's basically means that I think we'll still be very close to our PEA capex and opex numbers that we published, which is very, very important in this market where we see lots of rare earth projects around the world blowing their capex numbers. I'll let Roux just highlight some of these optimizations we've achieved at Mintec in South Africa, which are very exciting for Rainbow. Roux?
That's right, 100%, George. The piloting and test work and optimization efforts that we've been able to run at Mintec revolve to a large extent around impurity management. We've been able to successfully decrease the complexity of our entire flow sheet by finding a very effective and economic way of managing one key impurity, fluorine, in our flow sheet, and that has allowed us to move away from the typical rare earth fluoride precipitation and acid bake process that we had in our PEA. The optimization that we've been able to achieve with the fluorine handling has allowed us to simplify the flow sheet significantly, as well as remove usages of many hazardous reagents like hydrofluoric acid and the usage of high temperature operations like sulfuric acid baking, which also emits large quantities of noxious fumes and off gases that has to be handled and treated. The ability for us to manage fluorine in this way has allowed us to revert to a typical 3-stage countercurrent leach, followed by purification via ion exchange technology rather than precipitation and high-temperature concentrated acid baking. Some other optimizations that we've been able to achieve is materials of construction selection. In the PEA, we had very conservatively selected very high cost, but also very high quality, high nickel alloys, which we have now found is not necessary in our updated flow sheet. And we can now build most of our plant with very standard duplex grade stainless steels, which are much lower in cost and maintenance. The running of a continuous ion exchange process at Mintec has proven to us that we can significantly purify our rare earth streams, much improving the downstream separation of these rare earths. As you may know, when we are targeting 99.5 and above % in the rare earth oxide purity, it's imperative that we remove as much of the impurities as possible. And we have, in our continuous ion exchange piloting at Mintec, proved that we can achieve this to a very large extent.
As Roux mentioned, these optimizations are very significant. We've also reduced our heating requirements from 40%, from 40 degrees Celsius down to 30 degrees Celsius. Now, ambient temperature at Phalaborwa is around about 20 degrees. So to reduce your heating temperature from 40 down to 30 degrees, it's a 50% reduction in our heating requirements, and obviously significant savings in that area of cost as well for the project. So we're very excited about these optimizations, and we expect these to follow through into capital and operating cost savings in the project. In terms of materials of construction, by running extensive pilot plant in South Africa at Mintec, we were able to subject numerous samples of specialty alloys and stainless steels into leach tanks while we were doing our pilot plant runs. So we saw the degradation of the stainless steel across various types of stainless steel over an extended period of time, which has allowed us now to make selections which will also have those savings. So all in all, I mean, I always said, if you go back to my earlier interviews, that we always were going to run an extensive pilot plant. We were not going to take any shortcuts. And if the test work led us in a direction that meant that we had to do further test work and further runs of the pilot plant, this is far more beneficial to have, to come out with the right flow sheet, even if it takes us 6 or 9 months longer, because down the line that will save us a lot of money, not only when we build the plant, but by making sure we build the correct plant first time out. We don't have any hassles when we're commissioning the plant, and we've seen some projects around the world where they've tended to rush things, and this comes back to bite them. And as an engineering team, when we all worked at MDM Engineering, when we managed test work programs and designed plants on behalf of clients, we saw when clients took a shortcut and tried to rush things because they had market deadlines, how it bit them, and it doesn't pay in the long run. So we've been very steady with our test work program. We've been very open to say that we will do the correct stages, we'll do them correctly to make sure we've got the right result. Because by achieving the correct flow sheet, optimal flow sheet, it opens up a huge addressable market for Rainbow in terms of other opportunities around the world. So that's why it's very key to spend a little bit longer to get this pilot plant operation correct and get the right result. And that's why we've moved the pilot plant now from Florida down to South Africa, because we recognize that we need recirculating loads going from the front end to the back end and vice versa to maintain our overall recovery of rare earths from the gypsum, which is sitting at 66% recovery rate, which is very, very good for our rare earth project. And we realize that we need to run the 2 pilot plants on one site in South Africa, hence our movement of the pilot plant. And in South Africa, by having those recirculating loads, we are very confident that we'll be able to improve our rare earth purity from the 96-97% level up to that final 99 to 99.5% purity level.
Okay, well, George, obviously the pilot plant programme is an integral part of the work to deliver a definitive feasibility study for Phalaborwa, and you announced updated timings on completion of this by the end of 2025. Can you take us through the critical work streams to deliver that DFS?
So at the moment, the DFS on the front end of the pilot plant, which represents 75% of our flow sheet and roughly 75% of our capital, is on target to be complete in the first quarter of next year, as the original DFS was. But the fact that we realised that we need to move the back-end pilot plant to South Africa to run the continuous circulating loads between the front end and the back end, that's led us to a slight delay in that final stage of our DFS. All the other work streams are on target: the EIA, the stack design, the hydraulic reclamation of the phosphogypsum. All that's on target for the first quarter. It's just the final stage, and we are confident that we'll have that complete. As I said, we've said to be conservative by the end of 25, but I'm expecting it to be complete a lot earlier than that. What we are doing as well is that in late November, we're going to publish an interim number which will highlight these optimizations, which will also footprint our capital and OPEX, we believe, which will be very close to what we published in our PEA. And this will give the market confidence that our final DFS number will be very close to what we've published in the updated number in November. And I think the market will be very pleased when it sees that updated number coming out late November, as I said, just ahead of the final DFS.
Now, George, you recently announced a $10 million royalty agreement with Ecora, whereby they would take a 0.85% royalty for $8.5 million, and they took $1.5 million in equity. Why did you decide to go down this type of funding route, and how does this leave the company's funding position?
Well, it's a good question, and I'm pleased to say that one of the key reasons why I went down this route was to protect dilution at Topco, and being I think the third largest shareholder in Rainbow. This is very close to my heart. And basically, what's very important about the Ecora deal is, we had extensive independent technical due diligence on our process, and we obviously passed that with flying colours. Likewise, when we received a $50 million equity commitment from the DFC out of Washington in December last year, we were also subject to independent third-party due diligence on our technical process. So we've had two independent third-party DDs done on our technical process, and we've come through both of those with flying colours. But back to Ecora, the key thing about Ecora, similar to the $50 million from the US government via the DFC, it's based on the value of the project, not on the share price. And likewise, Ecora's $8.5 million is based on the project value and not on what the share price was at the time. And another key point is that because Phalaborwa is not deemed a mining project in South Africa, it's a chemical processing project on a chemical brownfield site, we do not have any mining royalty on this project in South Africa, or if we're in some other country. Most mining jurisdictions have a government royalty on all mining projects, and which would be anywhere between 4 to 6%. We have zero royalty, so 0.85% royalty based on the value of the project is a very, very attractive royalty for Rainbow. And the $1.5 million in equity came in at a VWAP, which was a premium to the spot price at the time when we closed the deal with Ecora. So it just shows us the confidence, or shows the confidence Ecora has in Rainbow and the team in Rainbow.
Now, George, while I've got you, can you give us an update on the macro trends driving the rare earths market and its pricing?
It's a very good question, because I've just come back from the International Rare Earth Mining Conference held in Toronto last week, held by Atmos Intelligence. It was a very, very good rare earth conference, and obviously pricing was a key topic in this conference. We've seen that rare earth prices have come off the bottom over the last 6 to 8 weeks. There's almost some 30%. Rare earth prices were at $47, $48 a kilogram for NdPr. A few weeks ago, we're sitting at about $60, $61 a kg, so almost a 30% rise. And what's driven us is we believe that there's been a destocking of the rare earth pipeline in China, and also at the prices we saw a few weeks ago, it was publicly stated, not only from Chinese producers, but as well as Western producers, is there a rare earth project in the world that could make money at these prices. So prices needed to start recovering. And hopefully we've seen the bottom of the cycle, and the trend in rare earth prices will continue. It was forecasted earlier this year by all the major rare earth forecasters, pricing forecasters, that is, that we would see stronger rare earth prices in the fourth quarter and going into the first quarter of 25. And it looks like they've been correct in their pricing assumptions. Another key driver that was very important that came out of the conference was that there's a massive growth in robotics and in eVTOL, which is electric vertical takeoff and landing. So, in other words, air taxis driven by electric motors. So, robotics, we already seen a massive increase in robotics. And just in LA last month, my son sent me a video of a robot delivering pizzas, so your driver for Deliveroo or Uber Eats on a scooter will be no more. In LA already, they're using robots to deliver pizzas to consumers, and they're also using drones to deliver small parcels. So the payload of the drones is running at about, I think, somewhere around about 10 kilograms. Now, the next targeted drones are going to have a payload of, I think, 40 kilograms, then up to 100 kilograms. So we're going to see more and more drone deliveries, more and more robots delivering services, and that forecast growth is massive. I mean, guys are talking about 1 billion robots in a few years' time, and all these robots require rare earth magnets, permanent magnets. So massive. So between 2030 and 2040, the conference saw robotics demand outpacing electric vehicles as well as wind turbines. And then the eVTOLs, the air taxis, they are going to use a massive amount of rare earth magnets as well in their electric motors. And already there are 2 airports in the US that have applied for licenses to start taking passengers from LAX to central LA and from JFK to Manhattan using these electrical vertical takeoff and landing vehicles, which are basically small helicopters that use electric motors. So very exciting forecast growth for these uses for permanent magnets. So basically the macro trend is not going anywhere. It's firmly up for permanent magnets, and that means for rare earth elements that go into the permanent magnets.
So taking all of this into consideration, including the delivery of pizzas, how is Rainbow positioning itself in the global rare earth market? What are the longer-term opportunities?
Well, as mentioned, we are extracting rare earths out of phosphogypsum, so a very green source of rare earths. But very importantly, we were able to identify a similar project in Brazil with Uberaba, which is a 50-50 MOU we signed with Mosaic, who are a global fertilizer producer. I think they're about a $12 or $14 billion business. The fact that Rainbow were able to sign a joint venture with a company of this size, I think gives credit to our team. And basically, we slowly, behind Phalaborwa, we are developing the opportunity to extract rare earths from the current arisings at Uberaba. And our team was in Brazil just 2 weeks ago. We've released some initial positive results on the grade of the rare earths that we see in the phosphogypsum at Uberaba, and now we're looking to define a resource out of the phosphogypsum, as I say, the feedstock that goes into their plant, and we're expecting very exciting results out of Brazil. And what this is doing is, as I said, it's opening up a huge addressable market for Rainbow. We've had approaches from other projects now in Canada, in India, and Saudi Arabia, all looking to partner with Rainbow. And these opportunities are coming to Rainbow. We're not going out and looking for them. They are coming to us. So we've got lots of eyes on Rainbow. And what we are doing is quite unique, but using standard sort of mining equipment and reagents and resins in our flow sheet, but we're using continuous ion exchange and continuous ion chromatography, which are proven technologies, but in a slightly different application to extract rare earths. That, as I said, these technologies are already used commercially successfully in other applications, but Rainbow are groundbreaking in this and how we're using them for rare earths. And this is very exciting for us. So I think we're well positioned to be a multi-project rare earth company and probably the lowest cost producer of separated rare earths in the world.
Many thanks, George Bennett, Chief Executive, and Roux Wildenboer, Senior Metallurgist of Rainbow Rare Earths. Thank you very much indeed for joining us.